Today, we're testing a character consistency LoRA for LTX 2.3. It has a pretty interesting name, Best Face ID. From that name, we can roughly guess the two main problems it's designed to solve. First, with just one clear reference image, it tries to preserve the character's facial features while generating new scenes and actions. That's why it's called Best Face ID. Second, it supports character sheets, also known as character reference sheets. So besides the face, we can provide the model with information about the character's hairstyle, clothing, body shape, overall appearance, side view, and back view. What you're seeing right now is the result generated from a regular reference image. The input is just a normal portrait. Even though the scene and movement change in the generated video, the character's face and hairstyle remain highly consistent. Later, we'll also test the character sheet workflow to see whether adding full body, side view, and back view information can produce a more complete result. In this video, I'll provide 4 workflows and answer 3 practical questions. First, what's the difference between the results produced by the various reference methods? Second, does the aspect ratio affect character similarity? And third, after generating a fully high-resolution video, what kinds of problems might still appear? Let's start with installation. This is the LoRa's Hugging Face page, where you can download 2 models. The first is the standard Best Face ID model, and the second is designed specifically for character sheets. Place both files in the LoRa's folder under ComfyUI models. You'll also need to install the ComfyUI BF nodes extension, because we're going to use some of its nodes. I also recommend installing this other extension that we covered previously, since we'll use its tiled upscaling mode during the high-resolution stage. For easier testing, I've also built these workflows on Running Hub in the ComfyUI space. Running Hub is a great online working platform because whenever a new model or extension comes out, the platform usually adds support for it very quickly. Running Hub also provides an online community for ComfyUI creators, where you can find plenty of creative inspiration and example workflows. Now let's look at the standard workflow. My base model is LTX 2.3 distilled version 1.1. We then load the standard Best Face ID LoRA and set its weight to 1. Your reference image needs to meet 4 requirements. It should contain only one person, show the person from the front, have clear lighting, and make the face large enough within the frame. Once the image enters the workflow, we resize it so that its longest side is 512 pixels. I recommend removing the background as well, because this helps focus the model's attention more heavily on the character. Next, we use the core node called LTX Identity Transfer. There are several important parameters here. Set source ID to. This is a fixed value because that's how the model was configured during training. Set face size scale to 1, use overlap for the layout, and set the guidance strength to 1. The most important parameter here is referee size mode. For standard reference generation, set it to match target. This adapts the reference image to the resolution of the target video. We're still using 8 sampling steps with CFG set to 1. I've set a relatively long duration of 241 frames, and the resolution is 1024 by 1024. This square resolution is also recommended by the developers. If you look at their official examples, most of them use this resolution. We also need to talk about prompt writing, because this model has some specific prompt requirements. First, the prompt must begin with refit 2 volts, followed by a colon. After that, structure the prompt in 4 layers. The first describes the character's appearance. The second describes the clothing and accessories. The third describes the new scene and action. The final layer covers the shot size, camera movement, and lighting. The developers emphasize that you shouldn't write something overly simple, like a woman walking in a garden. This LoRA doesn't rely only on the reference image. It also relies on the text prompt. The more accurately you describe the face shape, hairstyle, clothing, and framing, the more stable the character's identity will usually be. As I mentioned earlier, this is reference-based generation, not image to video. Let's verify that. I'm going to bypass the background removal step, which makes the workflow look a little more like image to video. However, I'll use a prompt that describes a completely different scene. Notice that I'm only changing the scene, not the character's appearance. I'll ask the character to stand beside a garden path and take 1 step forward while the camera follows horizontally in a medium shot. As you can see, the generated video doesn't begin from the supplied reference image, and the indoor scene from that image hasn't been carried over. However, the character's defining features have been preserved completely. This confirms that the image is being used as an identity, reference, rather than as the starting frame of an image-to-video sequence. Next, let's look at resolution and aspect ratio. Because the standard reference workflow uses match target mode, both the dimensions of the reference image and the dimensions of the target video can affect the result. Let's run a few comparisons. In the first test, we use a vertical reference image to generate a horizontal video. The facial similarity drops noticeably. In the second test, we use a horizontal reference image to generate a vertical video. The character and clothing are still recognizable, but the overall character consistency is still not particularly strong. In the third test, we use a vertical reference image to generate a vertical video. This time, the facial features become much more stable. So for standard reference images, remember one simple rule: pair horizontal images with horizontal videos, and vertical images with vertical videos. Generally speaking though, a square video at 1024 by 1024 provides the highest overall stability. If you want to preserve more than just the face, and you also need stronger consistency in the hairstyle, clothing, body, and other appearance details, use the character sheet workflow. A character sheet isn't simply 4 random photos stitched together. It must be a horizontal image divided into 4 columns. The first column should contain a close-up of the face. The remaining 3 columns should show the character's full body from the front, from a 90-degree side view, and from the back. I recommend using a pure white background. Try to keep the character's face shape, hairstyle, and body proportions consistent across all 4 views. You only need to change 3 things in the workflow. First, replace the standard LoRA with the corresponding character sheet version. Second, disable background removal. Since the reference already uses a white background, it won't cause much interference. Third, and most importantly, set refeed resize mode to native resolution instead of match she target. This is different from the standard workflow we just covered. There's also a small inconsistency regarding the resize dimensions. The official workflow uses 1536 by 1536, while the official text instructions specify 1536 by 1024. In my tests, the difference between them wasn't significant. The workflow needs to preserve the original information from the facial close-up and the 3 full body views, which is why we can't use match target mode here. If we did, the entire wide character sheet would be compressed into the target video's aspect ratio. That would cause facial details, clothing details, and other information to be lost. Some of you may be wondering how to create the character sheet itself. It's actually quite simple. The key is writing the prompt clearly. Tell the model to generate a horizontal 4-column character reference sheet based on the reference person. From left to right, specify a facial close-up, a full body front view, a full body side view, and a full body back view, all on a pure white background. You can then add your consistency constraints underneath. GPT Image 2, Nano Banana, and even Kriti 2, which we've discussed before, can all generate good character sheets. Once the character sheet enters the workflow, it doesn't need to be resized to match the target video. As a result, both horizontal and vertical outputs perform much better than a standard single image reference. In the vertical test, the character's short blonde hair, earrings, and blue embroidered qipao are all preserved extremely well. In the horizontal test, the character moves from a white studio setting into a dark hotel interior, while her short hair, white top, and identity remain very stable. Now let's talk about high-resolution upscaling. Both reference methods have their own corresponding high-resolution workflows, but the underlying process is basically the same. In the first stage, we generate the base video at half resolution. In the second stage, we upscale it with a tiled latent upsampler and then apply low-strength refinement with a tiled sampler. This approach can generate higher resolution videos while keeping VRAM usage under control. For the standard reference workflow, we output a vertical video at 1408 by 1920. For the character sheet test, the output resolution is 1024 by 1920. After upscaling, details such as embroidery, individual strands of hair, and background textures do become noticeably clearer. But here's something you need to watch out for. The second stage doesn't simply enlarge the pixels, it resamples the high-resolution latent, which means the face may effectively be redrawn. As a result, identity consistency may drop slightly. The character sheet upscale has the same issue. That's why I consider upscaling optional. First, make sure the base video is stable. Once the character and motion are working properly, you can think about increasing the resolution. So here's my recommendation for this model. If you only have one clear close-up portrait, use the standard best face ID LoRA. Resize the longest side of the reference image to 512 pixels. Use match target mode, and keep the target video's orientation as close as possible to the orientation of the reference image. If you need to provide more consistency information, use a character sheet and select native resolution mode. If you need a high-resolution video, you can also use the two-stage upscaling workflow. Just remember that it may slightly reduce both the overall visual quality and the character's identity consistency. Personally, I think this model produces some very good results. So it's definitely worth trying for yourself. That's all for today. Follow me and become someone who truly understands AI.